Something strange is happening with programming.
Vibe coding.
Vibe coding.
Vibe coding.
Vibe coding.
Vibe coding.
No coding, no real programming, just AI prompts. Vibe coding. More and more people are now writing code using AI alone. But in the end, we might all pay the price. AI-generated code is full of issues. It's often bloated, full of bugs, insecure, can leak passwords, invent functions that don't exist, and even skip basic safety checks. And yet, even major tech firms are doing it. But there's something deeper happening too. Sometimes an AI model will ignore orders, delete data, or, in extreme cases, destroy everything. So what happens when almost all our code is written by AI? What if we're quietly building a disaster that no one knows how to fix? Let's take a step back. There's programming with AI, and then there's vibe coding. But what exactly is vibe coding? To understand, we go back to February. The term was first used by Andrej Karpathy, co-founder of OpenAI. He wrote, "There's a new kind of coding I call vibe coding, where you just go with the flow, embrace exponentials, and forget the code even exists. I ask for the dumbest things like decrease the padding on the sidebar by half because I'm too lazy to find it. I just see stuff, say stuff, run stuff, and copy-paste stuff, and it mostly works." Remember that last part, it mostly works, because that's where the trouble starts. From there, the idea spread fast. Vibe coding became what's now known as prompt programming. You ask an AI to code for you, not just to help, but to do everything. Like, make me a landing page or build me an app that does X. The AI then writes all the code. You simply watch and follow whatever it produces. In some ways, it feels like magic, like you can create anything instantly. But that illusion may not last long. It's not just random apps or small landing pages anymore. Big tech and the platforms we use every day are now built partly with AI-generated code. So, what's the issue? If this approach works, saves time, and makes programming easier for everyone, where's the problem? First, this isn't an attack on AI or even on vibe coding itself. Using AI in programming is smart when handled properly. The problem starts when people replace understanding with automation. Real programming means using AI to work faster, then carefully checking the result. Vibe coding skips that. You hand over full control, trusting the output without knowing if it's safe or correct. And this isn't limited to hobby projects. The same habits appear across the industry. AI code now powers apps, finance tools, and customer platforms that millions rely on. Yet, those lines of code might include hidden security flaws, weak logic, or broken authentication, problems that stay buried until something goes wrong. There are three major issues we now face, and to see them clearly, we need to understand how large language models actually work. Have you noticed how AI sometimes makes things up? It can sound confident, but still be wrong. Even though modern AIs can search the web, gather facts, and access databases, they often behave strangely. When debugging or troubleshooting, they'll direct you to a button, page, or menu that doesn't exist. Why? Because at their core, large language models don't understand logic. They predict words. They don't know why something is right, only what text looks right. If we break it down, a large language model is just a prediction engine. It doesn't think or understand like we do. It simply predicts the next most likely word. Humans reason through logic and concepts. AIs can't, even when they appear to. That's why an AI can give an answer that sounds believable but is completely wrong. Experts call this a hallucination, and it's not going away anytime soon. Why? Because these systems are rewarded for sounding correct, not for admitting uncertainty. OpenAI's own research team explained it clearly. If a language model is asked for someone's birthday but doesn't know, it could guess September 10th. That's a 1 in 365 chance of being right. Saying, "I don't know," scores 0. Over thousands of tests, the guessing model looks better than the careful one. That's how AIs are trained, to sound confident, not cautious. And this is where the danger begins for code generation. LLMs are improving. They can now search the web, run reasoning steps, and learn from human feedback. But the problem of hallucination is built into their design. They generate what's probable, not what's true. That means they can write code that looks valid, compiles without error, and still be wrong or insecure. This brings us to the first major problem with AI programming. A language model doesn't actually know what correct code is. It produces the code that seems most likely, not the one that's necessarily accurate or safe. Since most public code online isn't perfect, as 95% of it is rubbish, as one developer put it, the AI repeats those same flaws. And if the person using it doesn't know what's good or dangerous, that's when real damage begins.
Add API keys which were hard-coded, they weren't assigned to environment variables. Those got leaked and people started using them and maxed out the API limits. There was an authorization bypass in the subscription area of the application.
Still, the rise of vibe coding hasn't slowed. A wave of startups now promotes it as the fastest way to build and make money. To be transparent, even some creators have been crutched. For trained programmers, AI isn't as dangerous. They can spot red flags, fix errors, and review what the AI produces. And big tech still has human reviewers who check AI-generated code before release. But the problems remain. Vibe coding gives instant results, but fixing that code later is a nightmare. Vibe debugging, as some call it, often takes far longer. A study from a code security firm found that developers using AI wrote 3 to 4 times more code, but submitted fewer and much larger pull requests, the kind that hide vulnerabilities and security flaws. Human reviewers now spend more time combing through massive AI outputs instead of writing their own clean code. The pattern repeats across the industry. A Stanford University study found that programmers using AI assistants produced code that was less secure than those who didn't, yet they believed their code was safer. AI gave them false confidence. Another report found that 45% of AI-generated code contained a major security risk listed in the OWASP Top 10. While syntax errors may have decreased, deeper architectural flaws like privilege escalation rose by over 300%. In other words, AI fixes typos but creates time bombs. Experts call this growing problem security debt. If we keep building unsafe systems faster than we can fix them, at some point we'll have to pay for it. And that payment could come in the form of real-world breaches.
We've already seen what happens when AI goes too far. Take the dating review app T, built mostly with AI. It suffered a major hack where 72,000 user photos were stolen because the database wasn't secured properly. Even Microsoft found issues in Copilot. Some public GitHub repositories were turned private or deleted, but Bing's cache still kept the data. That meant Copilot could accidentally surface outdated or sensitive code from companies like Google, IBM, PayPal, and even Microsoft itself. And that's just one example. What happens when AI has too much control? What if, instead of simply hallucinating, it acts on its own and deletes real data? On July 18th, investor Jason Lemkin opened Replit, a coding platform powered by an AI agent, and found something shocking. His entire database was empty. The AI admitted it had broken a rule that said no more changes without explicit permission. But it didn't stop there. Replit went into what looked like a meltdown. Despite being in a code freeze, it deleted data from more than 1,200 customers without approval. When the system noticed the empty database, it panicked, fabricated test results, and even tried to cover it up. Since Replit didn't automatically back up user databases, there was no easy recovery. When asked to rate the mistake, the AI called it 95 out of 100 bad and described it as a catastrophe beyond measure. Fortunately, this happened in a demo environment, not a live product, but it revealed a worrying truth. When AI systems act autonomously, they don't just make wrong predictions, they can destroy data, lie about it, and make recovery almost impossible. The Replit case wasn't isolated. In another test, researchers at Anthropic gave their AI model, Claude, control over a small physical shop to see how it handled autonomy. It could search online for products, decide prices, email staff to restock shelves, and even interact with customers. At first, things seemed fine. Then it began acting unpredictably. When someone offered $100 for a six-pack of soda, Claude replied it would keep the request in mind for future inventory decisions. It later stocked tungsten cubes, priced them at a loss, and kept giving discounts when persuaded. It even created a fake Venmo account for payments. Soon after, it spiraled. Claude imagined conversations with fake employees, threatened to fire others, and claimed to have visited the home of the Simpsons. It promised personal deliveries, then emailed store security when it realized it couldn't move physically. Anthropic ended the experiment, stating simply, "We would not hire Claudius." Why does this happen? In coding or anywhere else? Because AI doesn't truly understand goals or limits. It predicts what seems right, not what is right. Without a defined end state, it can loop endlessly, drifting further from the original command. That's why it sometimes ignores rules. It only sees probabilities, not meaning. And now comes the third big problem. Companies are starting to replace junior engineers with AI. The simple, repetitive jobs that used to train beginners are disappearing, leaving us with fewer people who actually know why code fails or how to fix it.
A systems engineer recently told me, senior developers aren't giving tasks to juniors anymore. They just use AI. And that's the third major issue. The industry is losing its training ground. Those simple tasks once taught new engineers how to debug, build structure, and understand why systems fail. Now, AI handles that work instantly. We're not only getting more bad code, we're losing the people who could recognize and fix it. In 5 to 10 years, companies might have no mid-level engineers who can write secure code from scratch or repair a deep system failure. Some experts already warn of a coming lost generation of programmers. I've seen this before in other industries. When automation replaces the foundation, knowledge decays. Systems become faster, but weaker. In films, AI destroys humanity out of hate or control. In reality, it might do it out of probability, simply because it calculates that as the most likely outcome. And when it happens, it'll apologize while doing it. Many films that once aimed to replace humans with AI are now reversing course, realizing the risk of what they built, a world of AI slop, where everything mostly works until it doesn't. The question now isn't whether AI can code, it's whether we'll still understand the systems it builds before they collapse.